Okay, it looks like we are live. Welcome back. Today I'm going to be continuing to work on my virtual machine. So, last time we started implementing string operations. They're not finished yet because I did have to go. Had some internet issues last time, but should hopefully be better now. If it happens again, then I'll probably just end the stream there. But yeah. So so let's look at test.tasm. That's what we're working on. So basically, we want to be able to swap the string, just like this, and then basically just swap the string, and then the index will change. So get_1 will be test instead of test2. So that is what we want to happen, but that's not exactly what happens. So if we run this, string stack underflow. Okay. So I don't know why that is actually. So I guess there is quite a few problems. So let's go to swap stir right here. So this should be pushing the string. Okay. But it doesn't seem to be doing that. So let me actually print this, and then I'll rebuild, and then run it again and see what it says. So we just have the single test. That's quite interesting. Okay. So yeah, I didn't look at this at all since last stream. So I'm not sure what's going on exactly. Stack size. Yeah, so when we pop it here, we don't get anything. So actually, I might need to look at this implementation. We do minus minus, but do we actually want to do this here instead? Let me see. Alright, if we run that now, it's still underflows, but we did actually print it properly. So let's see. Alright, so let me put that back. Alright, so that is just a regular stack underflow though. That was the issue we were having. So when we set stir stack size equals, we're setting that here, and that was causing some weird problems. But actually, let me look at push string. Push stir machine. There we go. So here we do this. Stack size plus plus. Alright, and then let me look in tasm.c as well. Stir stack size. Yeah. Stir stack size plus plus. Yeah. So, let me build all that. So we do have an issue. Stir stack, yep. This needs to be machine stir stack size. Just like that. There we go. Alright, so let's build that now. Didn't mean to build it twice, so... Alright, so it's still a stack underflow. Because that doesn't... Yeah, so that was the question we were trying to figure out. So, for some reason, we were stack underflowing, which was being called, here. Let's see, where is it? In the pop function. Yeah, right here. We were calling this. So I don't know why that was. Yeah. Yeah, so let me try doing that. Then we get data. Okay. So. Yeah, alright. Stir. Alright, yeah, right here. Let's do stack size minus minus. Okay, do that. And then up here, yeah, same thing, as well as in here. Alright, and then let me build it again. I made the same mistake, actually. It looks like, no, maybe not. 11G, yep. Okay, so this needs to be, yeah, I did make the same mistake. Yeah, there we go. Alright, so we still stack underflow though, so I'm not sure what that's all about. Oh, shoot, actually, I do know what that's about. It was that, syscall we were doing there. Alright. So get stir 1, and push 1, and then native 1. So that... Okay, so then that worked. No, it didn't work, right, because it didn't actually swap them. Yeah, so it just duplicates that one. So that is what we need to figure out. Okay, so So we're copying it here. And we're doing the same thing in here. So, yeah, let's see. So for some reason the pop function, no, it's this one. So we're not swapping it properly. When we push the string, let's actually print what we are pushing here. Then we can see test2, yeah, so for some reason it pushes test2 twice, so yeah, so with dupsir it does do that. So for some reason, yeah, but we can see here they are two different strings. Sir1, yeah, just as it shows here. So one is there. Yeah, so I'm not sure what that is all about. Something to do with the string copy. Let's actually print the string stack size as well. String stack size equals, and yeah, we can just print machine stir stack size right here. Okay, equals 1 and 2. But then when we get stir, oops, didn't mean to do that. Yeah, then we get an underflow. Test2. Okay, yeah, so test2 and then test2. So why is it not the right order? Push stir. So actually, let me add scope here, and then yeah, let's see, and then just find these like this, and get rid of. Actually, I'll just rename them. So to string 1 and string 2, string 1, string 2. There we go, and I will change the name here. String and ing. Alright, and let's see. So, unused variable, yeah, that's okay. Right, recompile it. Yeah, so it still does the same thing. Yeah. Actually, stir machine. So the string stack size does go down. So string stack size is 1. Huh. Alright, and let me go here. Yeah, okay, so underflow. So then the string stack size becomes negative. Yes, we don't want that. Build it again. Yeah, then we get data. So yeah, so it actually does work in that way. So I'm thinking I am thinking that, so let's see, where was it at? It was down here. Yeah, equals I. Test 1, and then still test 1. Okay, so that's not what we wanted. Mm-hmm. Push stir. So actually I need to change it in here as well. Alright, and let me see. So text.tasm and text.tim. Then they're both data n. So, that's not right still. Yeah. Okay, so right now we are basically one above where we want to be. Because, yeah, if we look at it once more. Yeah, you can see we have data n and test 1. So where's the test 1 coming from, actually? That's a little strange. -1. Hang on. Okay, string stack underflow. String stack under. Yep. So that's actually in the get string. Let me see. -1. Yeah, okay, so it is actually a little off. So in the popster, popster, let's see where. Okay, right here. Do we need to do like that? Yeah, so nothing should be negative. So that's not right. Well, and let me see now. Yeah, so -1, there was nothing there. See if we compile it. Test 1, and yeah, they both test 1, so that's not what we want. That doesn't work. Yeah, so that doesn't work. Like that. So, so that's why we need to do the -1, because otherwise we read data n. Yeah, so it's string stack underflow. Get stir. Equals that. So let's not add 1 to that. Okay, test 1. And then test 2. Okay, so that's actually what we want. Yeah, so the issue, it looked like it was in the get stir. We were adding 1 to it, which we did not want to be doing that. Because this works actually like this. Yeah, because that was just to account for the off by 1, but we didn't need that. So, that looks like it works actually. Let me push stir test 3, and then we'll save that, recompile it, and then test 3 and test 2. So, yeah, so 0 goes away then. Ooh. Ah. Test 3. Okay, so yeah, we lose 0. The 0th one for some reason. Yeah. So that is not good. Yeah, let me see actually. If we stir right here, we change this back to stir 1 and stir 2. Because those are allocated actually. Get that, and there we go. Yeah, okay, so that still doesn't fix it. Yeah, and then this is out of range, right? Yeah. So, okay. We actually do need to do something though if it is too little. So actually, let's do get stir. Get stir. There we go. Yeah. If it is greater than that, actually, so this will just be out of bounds. Out of bounds. Something like that. Or index is less than 0. Basically, is what we want. Yeah. And that should give us an error. Okay. Whoops. Chasm. Chasm 10, and okay. Yeah, so we don't get an error for 0. That's what we want. Yeah. So that should be fine then. So now let's take a look. So let's see why it is erasing it essentially. The 0th index. Because, well, so if we don't swap it, let's say 0. We still don't have it, so it's not actually erasing it. It is now an issue with our string stack. Ooh, it's probably how it's being pushed. So, Alright, so that is out of bounds. Yeah, so it is an issue with that. So, actually, that could be when we're reading. Read, yeah, right here. So we set it. Source stack I. And you do I++ at the end of that. Yeah, so the 0th one is not the correct one. So do we need to... Let's see. What is stack size equals? So where are we in initializing stir stack size? Yeah. It doesn't... We aren't initializing, are we? Yeah, here, machine.stir stack. No, that's not the stir stack size actually. So where is that being set? Yeah. That's somewhere up here. So where do we set that? Okay, I guess. Let's search for stir stack size. Where do we initialize that? I don't understand where it's coming from. So, yeah, so here we're setting it in the machine. But I don't see where it's actually initialized. Yeah. So I don't remember what I This is a mess. Yeah. So we have the string stack, but where's the size? So yeah, I'm not sure. Let me go up here and do insert stack size equals 0. So what if we do that? Okay, so we get that, and then 0 is out of bounds. That's weird. So why is that out of bounds? Okay, now everything's out of bounds. That's not very good. Yeah, so I definitely messed the thing up. So we don't want to set it to 0 there. It's 0. So what if we do that? Okay, that doesn't work. Yeah, I don't understand where we initialized that. I don't remember. I don't see it anyway. Let me make this a bit easier to read. There we go. Go like that, and then okay, yeah, and that looks a bit better now. It's still not like perfectly aligned, but that's okay. So, string stack size. Actually, is it defined in the header file? Yeah, so that's where we define it actually. Yeah, so I forgot about that. So that should be fine actually. But then 0 is not getting set, so yeah, so that is not right. Whoops. So let's see. Okay, so that should not be S1. So that should be at the 0th index. So when we're reading it here, so we initialize I at 1. So that is actually where our issues are coming from. Yes. So I need to start at 0 though, but I know that that breaks some other things. Yeah. So where do we iterate index actually? Alright, what if int stack index equals 0? Temporary solution. This should get it to work. So stack index. Yeah, and here as well. Stack index. Just anywhere we're supposed to be indexing it. Yeah, we can do stack index plus here. And let's see, does that actually help us? So then this test 1, and then that should be test 2, and then that should be test 3. Okay, so that actually works now. Yeah, so now let's try the swap stir, and then that should be test 2 on the top. So test 3 is on the top still. Okay, so that is not good. Yeah, because now this is broken. So that is quite interesting. What caused that to break? So in here, we're not doing anything different. Yeah, so let me actually see. Let me see. So, swap stir. Where do we have the get stir? Yeah, this one. So if we let's see. So The issue is with that, so in there, actually, yeah, so we don't want to read that. So that is why we do that. So let's look at stir right here. Yeah, so let's do stir stack size. Actually, I think we can do it just like that. And then rebuild it. Alright, test 3 is still on the top. Yeah, so then it does that. Okay. So that doesn't work either. Okay. So why are we getting data in when we pop it off? Alright, so then we get nothing there. Let's not add something. Tire test on him. There we go. So yeah, then we get so man. Alright. But this actually, instead of having a whole other stack index, we can just do I minus 1. Yeah, I minus 1. And then here as well, I minus 1. And then, yeah, we don't need a stack index at all. So where do we actually use this index that I was looking at here? This index, okay, we add that to it. Oh, here, for seeking. Okay, yeah. That is fine. So yeah, so that doesn't work still. String stack size is 3. So that is what it should be. Equals. There we go. So yeah, right here, and then we iterate it up from there actually. So that is 1 too many. Yeah. So it should be 1 less than that. Size equals I. Yeah, so that's why we did the minus 1 there. But then it still doesn't work with that. Yeah, so then it should be 1 and then 2, and then it becomes 3. And that's the right size, but for some reason right at the top, we have data n. So okay. Or that is there. Oh, shoot. Okay. So we're checking this. I think we want to kind of just get rid of that. But so why is it at the top of the stack then? So, if we use that as an index though. So we can't. So let's look at the pop stir again. And let's printf the machine stir stack size like that. Let's see then. So it's 3. Yeah, so that's why we have to subtract from it first. Yeah, okay, so test 3, but then we just get 2 test 3s for some reason. So stir stack size minus. Yeah, so why does that happen? 2. Let's get rid of that one. We'll actually get a problem, but we didn't recompile it. Yeah, so let me get rid of this right syscall. Alright, so that's what we've got. So those should not both be the same. So, yeah, we do that, and then let's also print the, right here. So that is the stack size there, and let's print the, machine stir stack size, no, stir stack, machine stir stack size, there we go. Yeah, so we'll print that, and then, send X, there we go. And then we'll see what that is as well. So, 2 and then 1. And so that's 2. Alright, so when we pop it off, it is right. Then when we push it again, it is wrong. Yeah, so machine stack the same as bonus. Stir stack size plus bank. That doesn't work. Machine is not a thing. We'll recompile the whole thing. Yeah, and same deal. So, okay. Yeah, so that doesn't quite work. Okay. Yeah. Need to fix that. So what can I do about that? Alright, I just had to make sure the string wasn't dead. Yeah, so let's see. We can move this back to how it was, actually. That was just testing. So, when we read it, again, let's look at that. Yeah, right here. Well, actually, let's look at where we're writing it. So we write it, stir line of that, I, so I equals 0. Yeah, so we write it at, starting from the 0th index. Data n. Yeah, so that should be fine. Stack I. Right there. So let me actually look at the test.tin file. Yeah, so that's what we got. 1, 2, 3, and then data n. So we do have all the right things in the right order. So when we read it from here, so we read it and we go through here. I-1 character index. Alright, so we're reading that until we reach one of those. So that's at the end of all these. They have that. Let's see, do we need to do that actually? So that's not right. Yeah, it's still not what we want. Swap stir. So, swap stir. Stir. So for some reason the value getting set here, just is the same. Because this is where we're printing that, and it's printing the same thing. But not when we pop it, or actually there. Swap stir. Yeah, right here. So if we print it out here, stir 1, stir 2, then, yeah, it is correct. Let me actually get rid of that. Yeah, it's correct, test 3 and test 2, but then when we push it, it's just that value. Let's see, let's go back to this. Alright, is that I think is the only place that we use these, so we can just get rid of that. Alright. So 1. Yeah, so let me do the same thing here. There we go. Alright, so we're swapping the strings, but it doesn't work. A and B. A equals pop, B equals pop. Let me recompile this whole thing. Yeah, so here is where we're printing this. Test 3 and test 2. And then we're trying to push that in this order. So test 2 will be on the top, but it's just test 3. Let's print this here. Set of value. So yeah, test 2 and then test 3. So we iterate it up. Alright, test 2 and test 3. Okay. We get stir 2. No. 2. And then push 1 and native 1. Okay, so test 3 is on the top. Yeah, so that's still not right. Okay. Yeah, so it is that's not really what we want to do either though. Okay, but then this is putting the right thing here. Yes, that's right here where it's putting the right thing. But in the wrong order. So that's not good. And then test 2. So what if, actually let me look at, what is 1 gonna do? Test 2. Alright, so what if we switch these? Swap stir. Basically just like that. Build it. Recompile it. Test 3. Alright, so that didn't actually change anything. That is weird. Okay. 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 So test 3. So we should be pushing test 3 first, but for some reason it pushes that one first. No, because that's not the value we're pushing. Okay. Yeah, no. Yeah. Stack size equals B. There we go. Yeah, this isn't actually the value that we're looking at here. Yeah, I just made it stupid. Yeah, so it's still completely messed up. So why is that? I don't quite understand. Let me do stir for I equals 0, while I is less than machine stir stack size I plus plus, and then I'll just print stir stack I, and this needs to be machine. There we go, like that. Build that, and then we can see all of them. So test 3, test 3, test 3. Yeah. So that is index %d is that, and then I'll put I here. There we go. Build it again and run it. Okay, index 0, and yeah, so it's just replacing index 1 from 2 to be 3. So that's not good. So why does that happen? I don't understand it. Stack size equal. And then machine stack size. Okay. And there we go. So we can tell the difference. Yeah, okay, so equals 1. So it's 1 after we do that, so that's right. But then we push it. Push it, and it just... Okay. And it iterates the stack size properly. But the value is not right. So I don't know why that happens. Alright, swap stir. So let me do 1 equals 2 equals that. So yeah, this isn't gonna work, but let me see what happens. Stir 1 and stir 2. Yeah, so that didn't change anything, obviously. Next string size. Next string size. Okay, let's see. Yeah, so we're allocating it, and then when we do this, we can see that is correct. Test 3 and test 2. Stir 1 here, stir 2 there. So what if we don't call that second one? Yeah, so string index out of that. Let me change that to 1 actually. Alright, so that's 3. And what if we just put string 2? Then, okay, so that is fine. That's what we want it to be. Register 1. Yeah, then it just pushes it in the right order, but when we switch these, it gets completely messed up. So why does that happen? And then what if we stir 1 after that? Alright, then we break stuff. So and then if we do it in the opposite order, then it just places it in the correct way. Holy moly. So why does this happen? I don't quite understand it. Stack. I don't see how this happens. So, just push string. Yeah, I don't know what's happening at all. Let's print this right there. Okay, so after we do that, it actually, ooh, I know what's happening. When we pop the string, we're getting just the element that is indexed there. Yeah, okay, and then when it's getting replaced, we're overwriting. Okay, man, I am so stupid. Oh my god. Okay, so yeah, we return that element that is here. But then we need to actually, yeah. So let's actually allocate something for this. Result equals malloc size of character times strlen of machine stir stack machine stir stack stack size minus equals minus one. There we go. And then the result equals machine stir stack minus machine stir stack size, and then return the result here rather than returning the actual thing. Result, okay. Yeah, and then so we do that. Swap stir here. Let's get rid of that. Yeah, so it's still overwriting it. Push stir machine. Yeah. So when we copy it here, maybe we need a swap stir function. Well, actually, let's just grab this. Swap stir. Here, yeah, so this is how we copy it. So basically, yeah, I'm not trying to go back doing this because, shoot, this is more complicated than I thought. Yeah, we're replacing it. We need, so, in the pop stir, actually, pop stir, let's have this be, let's do that. Result stir in size, something like that. Delete all that. And then, basically, for int I equals 0, while I is less than strlen of machine stir stack size plus and actually this needs to go outside of that, so I plus thing I just completely messed up. Alright, I plus like that. Okay, and then we do result I equals machine stir stack size. No, I messed that up. Machine stir stack size. I. Let's actually do that there. Then return the result like that. Start to undeclared. Yeah, so I did mess a thing up. In size t. Alright, so we can just make this size t real easy, and then we don't have to worry about that. Okay, so let's do times machine stir stack size. There we go. Value undeclared. So where is value? Oh yeah, so that is this. Is causing some issues for us. So let me do that. String 1 is undeclared. Oh yeah, so we need to declare these again. There we go. Oops, and alright. Alright, okay. 3 and data in. Okay, so that's not right. There we go. Alright, so that's not right. Okay, yeah, so it becomes -1. Ooh, because we actually call this over and over again. Let me move that just right up to here, I think. Okay, there we go. So that looks good, actually. And then change this to 2. Okay, and then we get the right. Alright, perfect. So then 0. Okay, and then if we get rid of this. Okay, underflow. String stack underflow. So why is that? So that's in here. Is less than 0. Okay, let's do that. There we go. So that's fine. 0 and then 1. Okay, so finally, I think this is working. I'm going to clean this up a little bit. So basically, we can just do int length equals stir length of machine stir stack minus machine stir stack size. And then we can replace all of this with this length, and then as well here, so we're not calling stir length over and over again. Oops, that's the wrong place. Right here. There we go, length. Okay, so let me make sure it still works. Yeah. Yeah, so I'll just leave it int again. That's fine. And then, alright, so that still seems to work. Yes. So now that should be working. Yeah. So that is pretty good. And then we allocate it for the right size. Yeah, so that should be good actually. So then let's look at push stir. So since we're copying it, can we actually can we free it afterward? I'm not sure. After we push it, can we actually free the strings? Free. I'm not sure if there's a way, but we can take a look. Okay, right. We stir 2. Okay, yeah, so it looks like that still works. String stack size equals, yeah, I can get rid of this one. And then %d, and yeah, right here we can get rid of that. There we go. And now it should all be working, hopefully, as expected. So test 1, and then make sure that still works. Test 2, perfect. And then push stir another 1. And then asm entire, okay, and then make this 2, and it should be S2. Alright, perfect. So that seems to be working now. So yeah, so now we need to do a similar thing in the rest of them. Yeah, so let's actually do that. Yeah, so then here we can free stir 1, and I think that should work already. So let's try do stir. And let's see. Another one, and then, ooh. So that's not brilliant. Yeah, okay, so another one. Doesn't seem to be working properly. So, need to do something about that. Yeah, let me deal with that. Seems to read an extra character. Alright, so 2, yeah, 1, 2, okay. See, I'm not seeing it now. Register. Hello. Hello. World. And then build it. I didn't do that actually. Chasm and tire. Hello world. Okay, that looks good. And then 3 should also be that. Okay, so it looks like Dupster is working. I'm not sure about that extra character or where it came from, because I don't see it anymore. So I'll need to do some research on that. Let's see. So I don't think this is gonna work. Yeah, Getster. In Dupster. Oh yeah, we need to put an index. So let's do 0. So then yeah, then the top should be that same one. Let's see. Yeah, so string stack out of bounds. So it didn't work. Index Dupster. So let's look at how this is implemented, because I don't remember what I did. Push through. Yeah, so we just actually push that. So that should be fine. I think it should be fine. Maybe not actually. Let's see. 2, actually. Yeah, actually I was just doing that completely wrong. Yeah, so that seems to work actually. Assuming 0 is still good. Yeah, so that works. In dupe. And then let's do in swap. And then, yeah, so 0, well, so this would basically work the same as the regular swap. And it did not work. Okay. So that is good to know. So this didn't work at all. So let's look at index swap stir. There we go. And let's look in here. So we do that. Okay. Yeah, so stir machine. So what is this? Stir machine. And then let's just push stir machine value, and then that'll be on the top. And then we can copy that like this. Yeah, so we are doing this. So what is this doing? This is setting the next value. Huh. Yeah, this is interesting. We're not even, where are we using the index? Yeah, I guess we're not using it, because that's what that was for. Yeah, so I messed that up actually. Whoops. There we go. So let's look at, yeah, let me go back to that. Yeah, so let me, let's actually handle this the same way. Yeah, so let's go to here. So we have the pop stir, and this is how we are handling all that. So let me copy this into there actually. Yank that. There you go, just like that. So instead of the stack size, we just put the index. Yeah, so then that is fine. So the length should be right then. Yeah, so this, we don't need that. And then here, we're iterating over it. We're setting result equal to that. Okay. And then basically, so this is getting the index that we're looking at. Then basically want to pop it off, just like this actually, and then replace them. So this can actually equal pop machine. Whoops, I messed that up. Machine, there we go. And then let's see, I don't think we need this, because we can just use the push stir for that. No, we can't do that, because it needs to be at the right index. Ooh. Yeah, so let's get rid of that, and let's replace this with the index. Because now we get a copy of the index in result. And then we push the result. So let's do that. Push result. And then basically we want to set the value at the index, which is what we do here. Yeah, so let's see. We want to set it with temp value. Yeah, we can use that. Temp value. There we go. Alright, so let's see what that does. Oh, this needs to be pop stir, not just regular old pop. Alright, and let's see. So yeah. So we got the data end thing, which is not what we wanted. So somewhere is actually messed up. Let me see. Ooh, this we want it to be the index. Okay, test one. So yeah, and then this should be S2. Okay, and just double check. Alright, and this should be out of bounds. Alright, that works. And then what if we add another one? So test 3, like that. And then we swap it with 0, so then 0 should be test 3. And it is. And then 2, hey there, Kuryu, probably butchered that, but how are you doing? How are you doing today? Yeah, test 1. Alright, so that actually looks like it works now. Index swap seems to work. That is brilliant. Brilliant. So I think all of the string operations are working now. Let's see. So let me just double check all the operations that we have in here. So we added, let's see, pop stir works, dupe stir works, indupe stir, swap stir. I mean, it needs some more testing, but it works at least in the bare bones testing that I've done so far, at least. So that's pretty good actually. So in the to-do list, we can actually X that out. Okay, so that's one. Next one that I want to work on. So I'm going to add that actually here. This is something we'll do later. Basically, I need to add types. Yeah, add types in the VM and assembler. All right, so basically what we have right now, doing great. What about you? Well, I am doing quite well myself. Yeah, I'm very happy to get that done because I've been stuck on that for a while. So the instructions. Basically what we have right now. On the string or on the stack, just a regular stack, we can store a word and it can be any of these types. But the problem is that we don't know what the types are. So I think what we need to do is make a struct. And then this, we'll just call it data, I suppose. That's probably a good name. And that can contain a word. Yes, basically just word. Yeah. Or it could contain the type. So just the type. Let's actually make one of those. So type def enum. So this will have type. Let's see, int type. We'll do it like that because we have. I don't want to have conflicting names because I have some other stuff like that. Int type, float type, char type, and pointer type. Pointer type, I suppose. So we can have those, and this can just be types, I guess. Should it be that? Is there a better name for it? Maybe data types. Data type. Yeah, that's probably better. Data type, and this needs to be the type. And then, instead of having a stack of words, we can have a stack of data. Yeah, so data. Alright, so that's going to break a couple of things. Actually, a lot of things. But then we need a way of actually setting the type when we from the assembly, because right now we have the assembly and it's pretty easy to figure out what the type is of whatever we're working with, because we always push and then the type is easily figured out. So this is obviously a float, this is obviously an integer, that is going to be, well, actually we don't have strings, so strings work differently. We have character like that, that's easy to figure out obviously. And then we don't directly push a pointer. That's more if you want to interpret it as a pointer. So that one would be a little bit different. So it's easy to figure that out. So we don't need like explicitly to say int or whatever. But basically the problem is that in here, so we can set it, but we don't really have a way to. We kind of have to check each one individually. But let's see. So yeah, so each thing is going to have that. So actually, is that the way that I want to do it? So word and then type. Yeah, so we actually don't put it on there. We do that, we need to add that to the instruction. Yeah. So in the instruction, we need a data type as well. And this is just, we'll just call it data type, like that. Because we have the type, so this should probably be called like instruction type or something, but I don't want to go through and change it for everything. So we'll call this data type for now. Yeah, okay, so I don't have much time left at all. I have to go in like 10 minutes, so I'm going to try to get as much done as I can. So let me actually, let me just, yeah, I'll do that after. I should have pushed the changes before I started working on this, but I didn't. So, yeah. Alright, but yeah, basically we have that now. And this is where we need to set it in the instruction. And this is just an optional thing. And then, when we encounter it, yeah. So this is the type. So it'd be a push, and then the word value is whatever it is, and then the type. So, in here, right, so we encounter push. And then we can set, here we set the value. And then we need to set the instruction type equals type like that. And then here would be type float, here would be type char, and here it could be type pointer if we push no. It's actually pointer type, not type. Pointer type. This is int type. This will be float type, and this will be int type. Int type. Okay. So then we have the type. So let me actually see what happens now. I've got to compile this. Yeah, so we have a lot of problems here. Yeah, so this is sort of how we're interpreting it, since it's not just a union now. We have to change some things. So, to type word, yeah, so here the value, we need to, okay, yeah, so this actually breaks a whole lot of things. So let's start working through it. So pop stir, or just regular pop actually. Let's pop. So yeah, well, let's look at push first, because that is kind of, yeah. So we just push the whole instruction. That's not a good idea. So the value is a word, and then we also need to provide the type, I suppose. Yeah, so we can just do machine instructions IP dot data type, and then in the push function, we can create a data here, and then let's see. Yeah, so we need to take in a data type. We'll just do type because we can call it that here. Then here equals, yeah, and then this can just be, I think we can do something like this. Value equals value, and then dot data type equals type. Let's see, something like that, and I think that will help at least a little. So yeah, and there is a lot of stuff here. So maybe, all right, something is not right. Yeah, I don't think it likes that actually. So let's just create one. So data. Sorry, data. And then we'll do data dot value equals value, data dot type, data type equals type. And then yeah, we'll just pass that in. Okay. Alright, and let's see. So build it again and go all the way up to the top. Okay. Alright, yeah, so now we have to redefine this in the header file actually. Because we did modify this. So the push, where we define all the functions here. Quite a few. Push can just be changed like that. There we go. Whoops, I just closed the file. Yeah, thing.c, there we go. Push. There we go. And we'll build this again. And we'll see what's happening. So, alright, yeah. Now we have to, each place where we call push, we have to push, or give the correct type. So yeah, let's just go straight to that. So here we are pushing this. So this can just be pointer type. is that is what it is going to be. Alright, what else? What else? Let's see. Can we get up to the top? Let me reset this. And then, alright. There we go. So, yeah, we can just go through pretty easy. Anywhere else where we have push? Here we have push. And then this is, that is an int. So we can do int type. Alright, and then I will just reset this again. There we go. And then go up to the top. And string const. So actually, let's just search for anywhere we're calling const. Or push. And yeah, so here, result, this is actually going to be a, this is going to be an int type. And let's see what else. Yeah, so here it is an int type as well. Okay, and here we push pointers, so that's different. Push C, where else do we call it? Temp value. So that is where we are swapping it. So this we don't actually know, but we can do the temp value dot data type. And so this actually needs to be temp value dot let's see, what did I call that? Let me look up here. So dot word. Okay, yeah, dot word. Yeah, and this can be a data. There we go. Alright, let's see. Actually, let me just keep going through it. Push, and let's see the next one. Alright, so this is the same thing. So, machine stack index.type, and this can be, or actually, data type. So, or yeah, I call it just .type. So, whoops. I think I did dot data type. Yeah, so this needs to be just .type. Yeah, so data.type, there we go. Alright, so let me keep going. Push, alright, push, yep, went through that. So here we are pushing, that's all good. So here, so we need to do a dot, just a basically, push a dot data, and then a dot word, and a dot type, dot word, and a dot type, there we go. Okay. So, yep, those are the functions. So then here, push that as well as, let's see, this needs to be dot word dot as in, dot word dot as in. Okay, and then here we push a dot type. There we go. Same thing here. A dot type. Yeah, so this, yeah, so here we're interpreting it as that. So that's all fine. So actually, this is going to be an int that we are pushing, I suppose. Yeah, so we'll just do int type. Because on any of these instructions where it's going to be an int. Yeah, so we can do that. Same, basically with any of the regular arithmetic instructions, we are always going to be pushing an int. So, alright, yeah, so I'm not going to be able to get this all done before I have to go. So, yeah. Yes. So I'm gonna get as much done as I can. Yeah, so this is the last one. That is inferred to be int at least. There we go. There we go, and yeah, so this is the same thing. A dot, whoops, yeah, let me see. Yeah, so these ones are interpreted as int, so, or as float rather. So we can do float type as well. Yep, word